So the topic I'm going to talk today is about modern Android architecture. First, some disclaimers, of course. I'm not here to talk about the Tangerine mobile application. This is more about, uh, I will talk about some guidelines, patterns, principles that some of those we're using at Tangerine. Okay. So basically, I've been working on Tangerine for the last 2 years as a senior Android developer. Before that, I've been involved with Android since probably 2012. The time it was Jelly Bean. Before that, I was working as a senior Java developer, and then I moved over to Android because the same language, right? And then right now, I'm transitioning over to Kotlin. Everything is Kotlin now, and also I'm doing some backend stuff using Kotlin, right? So as Samir was saying, right, Android applications were very hard to tackle. Uh, and that was because of the APIs that are probably more than 10 years old. The best thing is that about 3 years ago, or more, probably four, Google has been publishing new libraries, which are making the whole Android development much, much easier. So this is the main topic for today, all right? So before that, we have to think about what is considered a good architecture. No? It's something that will provide a structure everywhere inside your app, whether it's iOS, Android, the backend. No? You have to think about the structure. What kind of standards, conventions, documentation itself, so anyone can learn about the stuff you're working on, coding practices, design patterns that will provide you a better quality of life as a developer. Because of that, you will have much accurate delivery times. And the whole architecture will be flexible under any use case that you have to implement. And it will follow a natural evolution with less or even no friction at all, which will make at the end fun to work with. And that's the key. Because if you have to wake up tomorrow in order to keep working on your app, but it's so convoluted, so complex that you really don't want to do that, then we have a problem. So let's say that this over here is your app, right? You can see different boxes everywhere. Everything is talking to everything. So there's no structure at all. And the main problem with that is it's convoluted. No? So we should be targeting to something more structure, where you know that if you change something, you know exactly how many things it will affect. And that's the key part on how you can evolve your app in order to add new features, right? So moving over, oh yes, there are a lot of talking about clean architecture, right? Where you define use cases, a sync navigator, and so on. Can you apply that in order to get a good architecture? Sure, if your code is shared across multiple projects. Because otherwise, if you are working only in Android and you apply clean architecture, you will just fill out your components everywhere, defining use cases for simple stuff in order to fit the proper model, and it will actually create more troubles in the future. All right. Now, because Kotlin right now, I believe there's a new tools where you can actually define all your business logic in Kotlin, compile and share the same binaries on both iOS and Android. So that will simplify more of the things. Probably that could be a better topic for another presentation. Now, in Android, what should I do, right? You have live data, view models, activities, data binding, view binding, navigation graph, etc. So you have a lot of different technologies right now available to you. But how all this comes together? If you go over the Google documentation, you will see that usually the code samples they provide are pretty basic, right? Hello world, and that's it. They don't provide a full-fledged uh, model in order for you to follow. They provide you different snippets, how to use the view model with live data, should you be connecting to the API, but that's it, nothing else. In the late years, many people have been talking about this single activity principle, where everything should be hosted by one activity. And some people start applying this principle without considering the different use cases. So you will have only one activity containing several fragments, and that's it. The correct pattern should be to organize everything inside your app by using modules. No? Yeah, even Android right now supports modules. Even more, if you want to apply the instant apps, you have to organize everything into modules. Now, without thinking about instant apps and this concept of inside Android about modules, you can even organize everything as modules in that, like a package, right? You have a feature, let's say the logging activity, everything under one package, your logging activity plus all the fragments. But it should be inside some activity because it will allow you to manage your data accordingly. No? So in this case, I have here a logging activity which contains a navigation graph. And inside that navigation graph, I refer into different fragments, right? Probably the first one is the logging flow. And probably the second one is the reset your password, let's say. In other cases, for example, a user wants to sign up, right? So you have a flow of different fragments, and at the end you submit all the information in order to create an account. So that could be by itself its own activity. And even more, if you define this as within its own module, you can have people signing up into use your app without they having to install the app itself using the instant app feature, right? And of course, after that, you can have your main activity by itself containing everything else, right? All your primary screens, and then different other features that involve more fragments, but within sub-navigation graphs. So in that way, everything is uh, within their own context. And this will allow you to scale up your app in the future without any problems. Of course, the navigation graph API right now supports deep linking. So I suggest you start applying deep linking at the beginning of any project so you can actually simplify a lot of things later on. All right. Now, how the view models fit into all this architecture? Now, you have to think about the view models as how you are going to manage all the information inside your app. There are a lot of data requirements around, like for example, if we go back here, uh, your main activity here, this one, may contain all the data for the session, right? But when the user logs out, you just kill this activity and you probably will go back to the login activity. So basically, these extension functions provided in Kotlin will scope all your data requirements depending on the level where you are at automatically. So you don't have to do something else like clean up or here and there. No, everything is going to be going away. The same for the navigation graph view model. You could actually cache all your data, like in the previous example, right, where we have this sign up activity that will define a view model at the navigation graph. So all the fragments inside that navigation graph will actually contribute on the sign up process. And at the end, you just pull all the data and then submit everything in order to create the account. Even more, if you have different kind of loading status, no? Let's say, for example, this is a catalog application. You are buying something online, and you can have here different carts, each one containing add to basket, no? A button. And probably if you tap over one cart, you can see the details of the product. And that product can also contain an add to the basket. And most likely, just like in Amazon, you can see more related products, which will transition over different fragments, which are the same, but showing different products, right? But each one of them will have a add to basket button. But then when you go back, you go over back to the basket. And now, if, for example, in some way, these API calls take about 5 to 10 seconds, who knows, right? You have to update some kind of loading process when you're adding to the basket. You can synchronize everything by having a view model that is, the scope for that view model is a navigation graph. So in this way, you can synchronize everything together without too much problems. Before that, before all these view models, these new libraries, you probably were using an async task running on a different thread. And trust me, trying to synchronize all that parallel operations, it was really a nightmare. With all these new components provided by Google, this simplifies a lot everything. The other suggestion, another principle or pattern, is to decouple the view from the Android framework. Most people think about the fragment or activity as a view, but no, the fragment or activity are actually the glue only between the view, the actual view, and the Android framework. Your view should be the binding, the XML that you define. So how can we decouple that? As you can see in this example, um, I'm using a different convention on the naming, and you will see why. Because usually you have nodes fragment. In this case, I'm naming my class fragment nodes. This is because I'm using view binding. Usually when you define an XML file, you use fragment underscore nodes. So in order to keep everything consistent, I just define my name of the fragment. And this binding is actually auto-generated by the view binding or data binding framework. And this will provide access directly into your views, right? And then from there, I will start creating different kind of extension functions that we will see in the next slide. Now, what are the guidelines here? Prefer to use view binding instead of data binding. And use data binding only when you must bind live data into your XML directly. Because if you are not using that feature and you are using this layout tag inside your XML, what the Android framework is going to do is going to generate a binding, this one, and it will extend the view data binding class. And that view data binding class has a lot of code in there. So if you are using just view binding in order to put some data without actually any observable pattern using live data, you are just wasting memory when you're executing your app, because it's loading an object that is extending view data binding that contains probably more around 1,000 lines of code. Okay. So here it is how you will structure your code once you have this binder and you define this in yellow, these extension functions. So your fragment, it will just put together everything, is the glue. You can see that the binder is actually representing the view. I just initialize that with my view model. And on the view model, this is nodes is a live data. I observe and then call an extension function on the binder, passing the data. In this way, I'm decoupling what the view should be doing when new data is arriving. And of course, these have to be here because the fragment provides the view lifecycle owner. Now, yes, we probably can pass the view lifecycle owner into the other one, but then your code will not look like um, more, the structure is going to be lost, right? In this way, you are saying, hey, by the way, this extension function should be called within the fragment. And this is the way we glue everything together. And this is the binding, right? So as you can see, here is the same auto-generated class, extension function, and then I just put everything here related to the view. In this case, I'm initializing, this has an adapter for the recycle view. I'm initializing the layer manager, and then setting, okay, for the nodes refresh, I just call a method on the view model in order to load everything. And this load will trigger a change on the nodes live data, which then I post on this method nodes, and then I just populate my nodes adapter. Any kind of changes on the UI should happen inside these extension functions because it will provide you more structure, right? Um, Probably a couple of years ago, you will see that the fragments themselves will increase in size. You just have to put more code in there, etc. Right? Even if we talk about activities, you will see that some activities are more than 500 lines of code probably. If you see that on your project, it means that you are losing control of everything. And there are better ways to do it, just like I'm showing you right now. So basically, define as many functions as required, depending on your view model observable attributes, no? The live data. So you can define, okay, I know what should happen whenever there are new nodes in here. So probably here is refreshing. I just this node refresh, I believe, is a full refresh component. I just set up the loading status, right? This loading actually is a live data coming in that is actually updating inside the view model. So whenever the data is available, it's posting the data, but also posting on the loading live data value of false. So I can automatically stop the refreshing. Now, these things has some benefits in the way you display the data. You know exactly where your code should be displaying the data, how you are going to transform the UI depending on the data that is coming, and even better, how you implement the UI. In this case, I'm using XML, but then later, when I want to upgrade to Jetpack Compose, for example, I only have to update these extension functions and nothing else. Most likely is by adding composable functions in here. And that's it. All your other components like the fragment is not going to be affected at all. Okay. The other one that is usually a nightmare to implement in Android is about what I'm calling as UX policies or UI policies, right? So you have your app and you don't know what to do, right? I mean, in some screens you have to show a floating action button. Sometimes you have to hide the bottom navigation view, or show a toolbar, or block the drawer, etc. Right? So this pattern actually simplifies how you publish each one of the fragments an activity has. So the activity is the main one that defines all the Chrome, right? The toolbars, probably is using a coordinator layout in order to provide automatic animations whenever you are moving around your different kind of buttons. Like for example, I can share you right now. This is an app, and you can see that the toolbars are hiding. This is basically the same for most of the applications you can see around. But you can see that whenever I go over a fragment, automatically the top toolbar disappears and the bottom toolbar is transformed by another one, right? So implementing this using the all approach where the activity has to do everything is very hard. By applying this pattern or like this, you just have to reference the navigation, the nav fragment that is included inside the activity, and then register a lifecycle callback. And in this callback, you will evaluate each one of the views, in this case, the fragments, and its policies. How can we implement this? Just define simple interface, right? In this case, for example, I define an interface checking for top toolbar, bottom, drawer, floating action button, and of course, setting the floating action button. If you use this approach, it's a simple pattern well, where each fragment is defining statically what it needs, and that's it. Once set, it will remain so for the life cycle of the fragment. But if you need the fragment to reactively define based on some user inputs, you can define another interface, but using live data, right? So for example, in this case, if we go over here, I have one, what says architecture, right? So this is using the UX policies live data, because whenever I click here, I just disappear the top toolbar. So it will not appear anymore, or the secondary one, or even more, right? I can still swipe. If I want to lock, and then I cannot change anything at all. No? So all these ways to define is totally orthogonal to the actual activity. No? I'm just saying, okay, for this fragment, I need this, and that. So wait a second. Yeah. So the activity will implement this, we'll call these extension functions. And for every single fragment inside that activity, I just check. Okay, if that fragment implements UX policies, I just call different methods, different extension functions. And for each one of them, I just start toggling everything that I need. It's totally orthogonal. Whatever you need to do is in here, and it will not affect any other activity, fragment, and so on. So this will actually simplify how you define everything, because if I show you the code, for example, in this case, this is the activity main, and the activity main right now is just this code, nothing else. And everything is synchronized by these extension functions that we define, right? Setup policies. I believe this is from another, yeah, this is not from another variant, but this is similar to the stuff I'm showing you. And you can see here that in this case, I have more different kind of patterns. It's because at runtime, I can change the behavior of the activity. Right now, this is the one that contains only a bottom toolbar with a drawer. If I want to change this to a different pattern, I just select, let's say, for example, a top toolbar with a drawer. The same, right? This is a drawer. Or I want using a bottom navigation view only. Or something more complex, let's say a bottom up bar, including a bottom navigation view, right? Yeah, sometimes this one has a bug probably within the libraries, where sometimes the secondary toolbar, oh, here it is, okay, now it's, yeah. Oh. So this is actually one activity, this same activity, but using different kind of bindings that I define. And for each one of these bindings, I just call a different way to set up the UX policies, right? So everything is kept consistent. You can change on runtime. Of course, this is not advisable, of course, right? Your activity, your design, overall design of your app should remain constant. Otherwise, it will be very confusing for the user. No? So you probably should be only implementing one of these, not everything here. Like for example, yeah, usually is this one, a top toolbar with a drawer, and for the primary screens. No? In some cases, you can see that it switches over to a back arrow automatically. You don't have to do that programmatically. It's automatically being set up by the libraries. All right. Now, how after putting everything together, you can see that the activity is a main coordinator for all these major UI components. So we have the activity, which is listening by these callbacks by the UX policies. But hey, the fragment itself can also contain a nav host container as well. So you can have the fragment actually notifying other fragment about these UX policies. No? Because, for example, if you're using a dialog fragment can contain another navigation graph. And you can use the same principles in order to apply these UX policies. Fragment, of course, is just to glue everything together in order to observe the data and notify the view. Each one of these have a different view lifecycle, which will allow you to manage the view models that you have in order to put together other patterns in order to use coroutines. No? Always use coroutines within the view model scope, because of the same reason that we were talking about view models at the activity level, navigation graph level, and fragment level. Whenever you start a coroutine on a fragment and the user goes back, that coroutine is going to be canceled automatically for you. so you don't have to do anything. But if the view model is within the navigation graph and the user goes back to a previous fragment within the same navigation graph, that coroutine is continue to be executing, of course, because the view model follows the scope of the navigation graph. So in that way, you can manage everything without too much complications. And finally, of course, repositories should be per use case, right? For example, you can have a repository that will group everything together for API calls related to authentication, another repository related to the sign-up process. No? And of course, the data models are marshalling all the data between the views, the APIs. Even if you have room database implemented, you can reuse the same data models to define all the tables in here. And of course, the JSON parsing related to the API responses. Okay. Now, one more thing is that every single app could be great visually, but if the backend is not properly defined, you will have to do magic tricks in order to tailor all the different responses coming into your app. So if 2021 your API backend endpoints are not REST compliant, then you have a problem. No? Because most of the libraries, like for example Retrofit, they assume that your backend is REST compliant. If it is not, then you will have to analyze every single response, and you may get some kind of false positives where you receive a 200 code, but the payload inside your endpoint determines that it's an error. So that's a problem, right? Also, try to standardize the way you are providing error response bodies when you get 400 or 500. This one is the, this, it depends, right? When I say that an endpoint should be ACID, atomicity, consistency, isolated, and durable, those are concepts usually attached to transactions, the way we are committing data over to a database, right? But it depends. It depends, and it's totally relative to who the caller is. For a mobile app, an endpoint should be ACID, right? Because if a user signs up and that API call returns a 200, it means that the account was created. There's no other way around. And it will go deeper and deeper, right? From an endpoint that is calling another endpoint internally, another microservice, that kind of post or put or delete that you are issuing should be also ACID because that's expectation. And of course, if your persistent layer is a database, let's say a relational database or any other kind of database, every single transaction that is committed is going to be ACID. So all this dependency goes down to the storage up to the client. For example, in this case, right? Let's say that your app is calling a sign-up process, passing some values, and you do a post to create a user. So this post internally calls another microservice, returns 200, no issues. But then, for whatever reason, you have to return something for the next steps. And in the next steps, you do two gets to another microservice for whatever reason. What happens if one of these two gates fails? We have a problem, right? Because then your sign up is not going to be ACID. Because if one of these API get fails, it will report probably a 400, but you already created the user. So from a mobile perspective, it's no longer ACID. You probably will have to do something here in order to roll back this create user. What else? Oh, your API calls inside mobile are very hard to synchronize. So if you have this kind of client server behavior inside your app where you make one API call and depending on the results, you will make another API call and so on, there's something wrong with your backend. Of course, it depends on the use case, no? But usually it should be better to consolidate, aggregate, and transform everything so your mobile app can only make one API call. That should be enough in order to fulfill the use case. Because otherwise, your mobile app will have to an API call, get the data, analyze the data, depending on that, make another API call, and so on. And that kind of use cases are very hard to synchronize inside the app. And even more, I would say that it's very inefficient because every single network call is very expensive on the app, right? And finally, do not cache at the HTTP level. I've seen several projects a few years ago, and most of them were caching JSON payloads, right? But JSON payloads are just text. So for every single cache hit that you get from that cache, you still have to parse JSON again. So you are only just saving the network call, but your app will still have to do several CPU cycles in order to parse all the JSON into actual data models. No? There are different options in here. Some people are using Room database in order to cache the data. In some cases, you cannot do that because it's sensitive data, for example. So there are options to define a SQLite in memory. So it is going to be better, of course, because SQLite is optimized to manage memory better than in the case you are caching at the HTTP level. Most likely, you are using a map or a dictionary to store some text, right? By using SQLite in memory, it's going to be much more efficient. And finally, and this is the last slide, nowadays, people are thinking about what kind of dynamic and static aspects of your app you have to handle, right? How you manage change, how you visualize the data, how you populate all the different assets that you have, or even more, how you can actually change the structure of the app, right? For example, in one card, you can see this structure. Other card, you may want to use a different structure in order to implement some kind of A/B testing. No? So some customers will receive the card on the left, other customer will receive the card on the right, and you want to measure that. What is the reaction? Which is more acceptable for the users? How you are going to transform and localize language, dates, amount, percentages. No, they are not the same. Here in Canada, because French and English are officially supported, then you have to make sure that all your content is properly formatted. And even more, in the future, you may have more different kind of content that you may want to um, manage in some way or another inside your app. One thing is, hey, I can have one fragment or one adapter showing this kind of card, another adapter showing another different card. But that will only get you up to some point. Because for every single change that you want on the way you present the data will require changes on the app. And that's a big problem. No? Because in the financial world, for example, whenever you have to change some terms and conditions, you have to force the users to download again your app. Otherwise, you are against the law. You have to update, or even more, even any kind of app, if you have to at a hard deadline in order to update your terms and conditions, one way to do it is publish a new version of the app and force an upgrade to all the users, right? So the trend right now is to use this kind of headless content management systems where everything is actually more focused on the structure, and then your app will use that structure in order to render everything dynamically. Oh, that's the trend. Uh, all right. So you can go over and visit this website. Where is it? Here, where I explain everything that I presented today. Okay. No ads, by the way. And there are links in here in order to go over this GitLab repository where you can see the code for all this application. Exactly the same code.
Awesome. Nice one, Miguel. Maybe if you want to put that link in the chat section so our viewers can take a look.
Okay,
See.
sure. Right. So you can actually use the code at your own discretion. If you want to quote me, no problem. Just add the link if you want to. But yeah, yeah. Unfortunately, I didn't have enough time to write more articles in here, but I'm trying to do that by the end of the year. But all these ones are mostly related to the presentation that you saw today. Okay.
Fantastic, Miguel, mate. Thank you so much for that. That was really thorough presentation there. So once again, it's time for hand clap emojis, ladies and gentlemen. If you want to put some emojis in the chat to show your appreciation for Miguel. And yeah, we'll jump into a couple of questions for you there, Miguel. We have a question from Mahan, who is our next presenter, actually. Mahan has asked, how would you say we got to go about implementing UX policies in other platforms such as iOS?
Oh, well, for iOS, I don't know because iOS doesn't have this concept of navigation graph, but most likely you will have some kind of implementation of a sync navigator where you can actually define that in there, right?
Cool. Next question we have is from Param. Param has asked, if we have a not ACID API and we need to call sequences of APIs in the mobile app for a single action, where should they be wrapped? Within repositories or view models?
Well, if that's the case, then yeah, they should be inside the repositories. Now, trying to make the app think about that there's only one call, but inside the repository you will actually orchestrate all the different calls sequentially if that is required. But unfortunately, it depends, right? Because if only one of them fails, is there a possibility on how you can roll back everything? Of course, the optimal solution would be to wrap all these different endpoints into another one, so your app can actually make one API call only.